Now, one of the important aspect of the arc welding process, that the how to decides or how to design the power sources for different welding processes. So, definitely there is a requirement of a power source to deliver the controllable current and voltage according to the welding process used. So, we know that specifically in welding process, the power source is used in such a way that high amount of the current and the low voltage, basically low voltage in the sense that around current range may be more than 100 amps and voltage is around 20 volt. So, as compared to the normal electrical connection. So, but this requirement for this requirement specifically used for the welding process needs to develop the different power sources, but there is another aspects also that during the process or when you create the arcs and to maintain the arc and to continue the welding process over the time. So, in that case two different characteristics of the power source can be defined. So, one is the constant current source, or other way it is also called the falling characteristic power source, and second one is that constant voltage or flat characteristic power source. So, these two different type of the power source, how the current or voltage can be adjusted during the welding process when we use some consumable electrode or normal electrode, or in the process if there is some change in the arc length, or if there is a presence of any agents or maybe surface oxide layers present in that workpiece surface, that actually tends to make some variation in the either welding current or voltage. So, based on this, the applicability of the power source in welding process is defined basically in these two categorization. Let us see that first one is the constant voltage power source. What are the typical characteristics of this type of power source and why it is required? First thing, if we look into that, this type of power source can be used in case of semi automatic arc welding process. That means, in semi arc welding automatic automatic arc welding process, there is a probability of variation of any voltage or current relatively small, since it is automated process as compared to the any kind of manual process. So, in that case the typically downward negative slope type of characteristic. So, that characteristics define the relation between the voltage and current. If you see from the figure that voltage and current, it follow almost linear, or in other way we can say it is a almost flat characteristic of the power source, that means relation between the linear relation between the voltage and current. So, this type of power source is characterized by that first is the sufficient internal electrical resistance and inductance in the circuit. So, that there is a small change in the current, probably there may be the changes accordingly, there may be the try to maintain the almost constant voltage by changing the current. So, change in current is accompanied by the process is basically the melt the electrode at the required rate. So, the sense of change in current is basically reflected by melting the electrode, so that it will try to maintain the constant voltage of the power source. Speed of electron as well also control the average welding current, and constant electrode wire feed basically is the self regulating or self adjusting, creates the self adjusting arc length of the system. So, in this case the preset always try to maintain the desired arc length by maintaining the constant voltage, but if during the process if there is a small variation of the change in the arc length, that is automatically adjusted by melting the electrode material, definitely in case of the consumable electrode. So, any change in the welding current occurs, in this case it automatically increase or decrease the electrode melting to regain the desired arc length. So, to maintain the desired arc length, it is also to maintain the constant voltage power source. So, figure if you see that from the figure that it starts from the open circuit voltage. So, that open circuit voltage is required when just to start the arc welding process, and then from the open circuit voltage there is a drop, but drop rate is very low in this case, and of course, it is a negative slope, and that actually desirable characteristic of the constant voltage power source, and of course, it is more suitable for the automation of the arc welding process. So, if you look into the another type of the power source, that is constant current power source. In this case, we can see from the figure the relation between the voltage and current can be represented like that. It is a non-linear way, and there is a sharp dropping of the voltage with a small change in the current. So, that is called the sharply dropping characteristic of the power source. So, definitely in this case, the during the welding process it is always tried to maintain the constant current, but by accordingly by changing the voltage. So, this type of power source is very typically useful in case of manual arc welding process. If we look into the manual arc welding process, it starts with the by sticking of the arc, that means by sticking of the arc, that means open circuit voltage is very high, and then after that, after sticking of the arc, then we will after that we try to maintain the constant arc between the workpiece or electrode. But manually it is not very easy to maintain always the constant arc. So, there is a highly chance of the desirable that there is maybe the continuous change in the arc load. So, that is accommodated by this type of typical characteristic power source. Now, if we look into that, definitely the high frequency unit supplies the high voltage, and along with the high frequency with low current. So, initially when you try to create the arc, that ionizes the medium between the electrode and the workpiece material, and so that it start the pilot arc, which ultimately leads to the start of the main arc. So, to maintain a change in the to maintain this type of arc welding process or to create the arc, it should follow this type of typical characteristic of the power source that starts with the very high open circuit voltage, and then the drop of the voltage is actually occurs in rapidly, and that follow very nonlinear path, and also it is a sharply dropping characteristic it follow in this case. So, this type of power source is basically desirable of the manual arc welding process, and it reflects that in change in the power source, that means open circuit voltage adjust and out and also control the output current, and that basically represented by the change of the slope, that represented by the change of the slope in this volt versus ampere characteristic graph of this type of power source. So, here you can see that two types of the power source, one is the constant voltage, another is the constant current. So, one is suitable for the manual arc welding process, that is the constant current power source is suitable for manual arc welding process, and another is suitable for the automatic arc welding process, that is the constant voltage power source is suitable for the automatic arc welding process. So, basic things is that if we try to sustain the welding process, that means after creating the arc and to maintain the arc gap between the workpiece and electrode, we need, depending upon the applicability of the whether it is manual or whether it is automatic, based on that power source can be set accordingly. So, apart from this, characteristic power source, we can find out that two different characteristic of the power source, and then we can find out that there is another important phenomena which happens in the welding process, that is the shielding gas. So, basic role of the shielding gas we use in this shielding gas in the welding process, but the main role is that to protect the molten metal from the contamination by the outside atmosphere. That is the main objective of using the shielding gas. Now, this is the essential part of the welding process until and unless the welding happens in vacuum. So, if it happens the vacuum, there is no question of the contamination of the molten weld pool or with the atmosphere. So, in that sense, each and almost every welding process normally a different way we can protect the molten pool from the outside atmosphere, and either using the direct using of the shielding gas or in different way. That means, we can create the slag coverage, and that is by the chemical reaction of the arc that happens during the chemical reaction of the arc. So, these are the two way to apply the shielding gas or to protect the molten pool. Now, what are the common shielding gas we use? We have observed that the different type of the shielding gases like argon, helium, carbon dioxide and oxygen, these are the typical shielding gas is used, but oxygen cannot be used alone, but always we use the oxygen mixing with the other shielding gases. Now, the shielding gases either we can use is 100% the, if you see the shielding gas is mostly the inert type of gas, so that it will try to avoid the make the reaction with the molten pool. That is why argon, helium, these are the typical type of shielding gas we use during the welding process. First, either the shielding individual shielding gas can be used alone, 100% of the shielding gas can be used in the for certain applications, or sometimes we use the mixture of the two different or more different shielding gases with different combination to get the certain advantage. But the basic role of the shielding gas or basic principle of the shielding gas actually relates to the reactivity, or shielding gas can be decided based on the reactivity of this shielding gas with the molten pool, or maybe during that high temperature environment, and what is the ionization potential of this type of shielding gas, that means how easily it can be ionized or not, and what are the thermal conductivity of the this type of gas or thermal conductivity of the workpiece materials. That also play important, these factors also play important role to choose the shielding gas. But basic point of choosing the shielding gas is that based on the whether it is very reactive with the at high temperature environment or not, or if whether by reacting with the workpiece material, substrate material, whether it can produce some defect in the welded joint or not. So, based on that we can choose the different type of the shielding gas. Now, these are the basic role of the shielding gas. Now, we will try to discuss the some overall idea or in general different fusion welding processes. So, these fusion welding processes we know that it is a broadly categorized this that welding processes, that fusion welding processes, non-pressure, that means without the application of the any pressure, or pressure welding, that non-fusion. So, without using any without, that means pressure welding, there is no fusion of the substrate material. So, but we will focus on the only on the fusion welding processes, some general idea about the fusion welding processes. So, that fusion welding is basically we can categorize in this way, that gas welding, a name of the different gas welding processes, that is oxyacetylene, air acetylene, oxyhydrogen. So, basically chemical sources by burning these gases, that this can produce the heat, and that heat can be used to fuse the to melt the material. So, this is these are the typical gas welding process we have used for joining of the metallic materials. High energy beam. So, if we look into that high energy beam welding processes, normally the electron beam welding process and laser beam welding process are two widely used the high energy beam welding processes. Third is the chemical based, that thermite welding. So, in that case some oxides is used, and during the reaction it generates the heat, and that heat is basically try to fuse the material. So, that is called the welding process, that is chemical based welding process. The one example of this thing is the thermite welding process. And apart from this, other are the other typical usable welding processes, that is arc welding process. So, arc welding process, in this case the categorized in the following way, that using the consumable electrode or using non-consumable electrode. So, consumable electrode, the electrode can be consumed during the welding process, and it becomes the final part of the weld joint. So, consumable electrode we can find out that shielded metal arc welding process, that is SMAW process mostly used, GMAW gas metal arc welding process, submerged arc welding process, and electro slag welding process. These are the most general the consumable electrode arc welding processes. And if we look into that non-consumable electrode, that is the gas tungsten arc welding process, plasma arc welding process, and carbon arc welding process. These are the typical non-consumable electrode process, but of course, it is a non-consumable electrode process. That means, in the sense that main electrode which creates the arc between the workpiece and the electrode material. So, in this case that electrode material is non-consumable, but it is possible to use some extra material that can be melt during the creation of the arc between the workpiece and the non-consumable electrode, and that extra material becomes the final part of the weld joint. And in this way, that using the filler metals, the non-consumable electrode arc welding process can also be developed. For example, in case of gas tungsten arc welding, sometimes we use the extra filler material in this case, but the main electrode is not consumable in this case. In that sense, it is called the non-consumable electrode arc welding process. So, with this fusion welding processes, we will try to give an overview of all these type of fusion welding processes. Although